Welcome back to the deep dive. Today we're tearing through a really fascinating stack of sources. We've got developer logs, some internal speculation, a few academic strategy papers, and a lot of market analyses, all published around the close of 2025.
And what they're showing is, well, it's not just a simple competitive update.
Yeah.
It's a technological earthquake.
Right. The whole pace of AI progress, it's just fundamentally shifted. We're no longer measuring it in the lifespan of products, over years.
Not at all.
It's measured in the speed of releases now. Weeks, maybe months.
And this is the crucial distinction our sources constantly, and I mean constantly, hammer home. The past year, 2025, has been defined as this decisive pivot point.
A pivot point, how?
Well, this was the year machines moved beyond simply talking. That's what really characterized the early 2020s, right? Plausible sounding text.
Cool. The chatbot era.
Exactly. Now, they're beginning to actively think, see, plan, and act. We are witnessing the first generation of systems that genuinely mimic complex human cognition, and it is reshaping everything.
Everything. And that exponential acceleration has, well, it's hypercharged the competition into what you can only call a true AI arms race. It's being waged fiercely between what are now very clearly defined as the three global AI superpowers. You've got Google anchoring its entire strategy around the Gemini family.
Right.
Then there's OpenAI just relentlessly pushing the envelope with their GPT-5 series.
And the third player?
And XAI, which is all about maximizing velocity and scale with the Grok 4 family.
Three very different philosophies clashing.
Okay, let's unpack this. Our core mission for this deep dive is to move past that superficial battle of, who scores highest on some narrow benchmark.
That's a fool's errand at this point. The lead changes too fast.
It does, and the sources are really definitive here. The question is no longer who has the best chatbot. The actual strategic prize is who is building the operating system for intelligence itself.
That phrase, operating system for intelligence, is the absolute anchor of our investigation. It's what this is all about. And to understand the future, you first have to ground yourself in the immediate present standard.
The baseline.
The baseline, which is set very recently, actually, November 18, 2025, with the launch of Gemini 3. That release was not incremental. It was a fundamental reframing of what a frontier model could be.
How so? What was the reframe?
It was truly agentic. It was natively multimodal from the ground up. And it was integrated so deeply into workflows that it actually started to dissolve the user interface as we know it.
And what follows from that decisive moment, it's this tidal wave of societal change that extends way beyond tech blogs and developer conferences.
Oh, absolutely.
We are not just dissecting features or, arguing about context windows for fun. We're examining the wholesale erosion of computing paradigms that we've relied on for decades.
The app model.
The app model is dying. We're looking at the brutal fight for control over your time and your attention, and the fundamental, frankly, existential implications for the post-work economy.
An economy that is now demonstrably arriving. This isn't speculation for 2040 anymore.
No.
Precisely. So if you, our listener, are trying to get ahead of the curve or even just understand the world you're living in right now, you have to understand the immediate present standard Gemini 3 before you can intelligently assess the tectonic shifts that are coming with Gemini 4 and its competitors.
So let's start there then, at the present moment. Gemini 3. The sources detail that it came in, two primary flavors?
That's right. You had the high-capability Gemini 3 Pro, which is the flagship, and the highly efficient Flash variant.
Yeah.
But the central technical leap, the thing that really set it apart, was its focus on agentic AI.
Okay, we hear that term everywhere now. It's a total buzzword. But what does agentic truly mean in the context of these massive models? How does it actually change their utility?
It's a great question because the term gets misused a lot. Agentic AI, as defined by the developers of the technical papers, means the system moves beyond being a reactive conversational tool. It's not just waiting for a prompt.
Okay.
It becomes a proactive worker that's capable of autonomous goal decomposition. And that requires 4 linked functions. They have to work in a loop. Planning, execution, evaluation, and iteration.
A loop. So it's not just running a single command I give it. It can actually figure out the necessary steps to fulfill a much higher level intent.
Exactly. Think about the difference. You can tell an old chatbot Write an email about Q4 earnings, and it'll do a decent job of that one task.
Right, a single discrete task.
A single task.
Yeah.
But you ask an agentic system something much broader, something like investigate our Q4 sales data, identify the 3 biggest regional anomalies, cross-reference that with the latest policy changes in those specific regions, then summarize the findings, draft a memo to the executive team, and schedule a follow-up meeting with the regional VPs.
Wow. That's not a prompt, that's a project.
That's a project. And the system has to plan the database queries on its own. It has to execute the analysis. It has to know that its first draft of the summary might fail. It might not be good enough.
And it can tell.
It evaluates the quality against known internal standards for what an executive memo should look like. And then, and this is the key, it replans the memo's tone. If the first attempt was, say, too formal or maybe too informal, it iterates.
That failure and replan loop, that feels like the real differentiator. That's the transition from, I don't know, a helpful assistant to a true cognitive partner.
That is the transition. And the efficiency of this agentic model is absolutely critical. You mentioned the Flash variant.
Yeah, the one optimized for deployment.
The sources repeatedly, and I mean repeatedly, emphasize the business implications of that Flash variant's efficiency. It is reportedly 3 times faster and over 80% cheaper than many competing frontier models for comparable tasks.
80% cheaper. That's not a small number.
It's a game changer. That efficiency doesn't just save money on your cloud bill. It fundamentally accelerates the deployment of these agentic capabilities across the entire Google ecosystem.
So into every phone, every browser, every document.
Everywhere. Because when the cost of a single cognitive step approaches 0, you can afford to have your AI take far more complex multi-step actions on your behalf, constantly. It just becomes ambient.
And the capability leap wasn't just about speed or planning. It was also about intellectual rigor. The sources talk a lot about the advanced reasoning and deep think mode that was introduced with Gemini 3. What is that?
Deep think mode is essentially the model simulating introspection. It's a fascinating architecture. When it's faced with a computationally hard problem, a complex math proof, a really deep coding debug session, or novel scientific reasoning.
The kind of things where older models would just hallucinate convincingly.
Precisely. Instead of just jumping to an answer, the model is engineered to pause its generation process. It stops. It reflects on the problem's constraints. It decomposes the problem into logical subproblems, and it generates an internal, multi-step plan before producing the final external output.
So it's showing its work, but to itself first.
Exactly. It's this structured, sequential thinking that is where older, purely language-driven models would inevitably falter. They'd produce plausible-sounding but fundamentally incorrect answers in these high-stakes domains.
Because they were just predicting the next word, not reasoning through the step.
You've got it. Deep think allows the model to maintain conceptual fidelity and logical consistency across hundreds of inference steps. And that is absolutely vital if you are entrusting it with something like designing a physical system or debugging a complex multi-threaded application. You can't have plausible guesses there.
You need correctness, and that structured thinking is then paired with a memory capacity that, well, it truly changes the game. The sources highlight Gemini 3's support for up to 1 million tokens of context.
1 million.
1 million tokens. For our listeners who are accustomed to previous models that would, struggle to maintain context beyond maybe a 20-page document, how do we even illustrate the impact of that number?
This is where it gets really interesting and, frankly, a little bit mind-bending. 1 million tokens is roughly equivalent to 1,500 pages of single-space text.
1,500 pages.
So what does that mean in practice? It means the model can ingest an entire multi-volume legal case file, or an entire year's worth of an organization's internal emails and reports, or a complete high-level code base for a major piece of software. And it can reason across the whole thing simultaneously, holding it all in its active memory.
So the system doesn't just summarize the documents one by one. It understands the internal contradictions between them, the subtle relationships between different sections.
The continuity of the project from start to finish, yes. The profound change here is that the model transitions from being a forgetful assistant that you have to constantly retrain and remind of things.
Constantly refeeding it context.
Right. It moves from that to being an accumulating, reliable resource.
Right.
I mean, imagine debugging a 500,000-line code base without ever losing sight of the initial commit logs from 5 years ago, the original design specifications, and all the internal documentation.
That capability alone would fundamentally alter how deep research is done,
Right.
how large-scale software development happens, how complex legal analysis is conducted.
It removes the necessity for the human to be the context bridge between all these vast data silos. The machine becomes the bridge.
But the memory isn't just about text, is it? It's about all forms of input, which brings us to another key technical achievement: native multimodality.
Yes, and native is the key word there. This is a significant technical differentiator that moves beyond the typical bolted-on approach we saw in older models.
What do you mean by bolted on?
Well, older multimodal models often stitched together separate engines.
Mm-hmm.
They'd have one for vision, another for audio, a third for text, and they'd use these clunky translation layers to communicate between them. It was inefficient and created friction. Gemini 3 was trained multimodally from the ground up. It processes text, images, audio, and video not as separate inputs that need to be translated, but as elements of a single coherent language structure.
So it's not thinking in English and then translating an image into a description. It's thinking in a universal language of understanding, regardless of the input medium.
You've nailed it.
Yeah.
And the practical impact of that is seamless, low-friction reasoning across mixed inputs. The sources cite a specific example that really drives this home: analyzing hour-long videos frame by frame and being able to reason about the content.
Give us the example.
Okay, so you showed a video of a complex medical procedure. Then you ask a question that requires correlating a physician's auditory instruction, what they said, with a tiny visual anomaly on the patient monitor at the 45-minute mark.
Wow.
For an older system, that's 3 separate difficult tasks.
Oh.
For Gemini 3, it's one continuous cognitive task.
Yeah.
It doesn't see a difference between the audio stream, the video stream, and your text-based question. It's all just information.
And this incredible capability is immediately integrated into the corporate ecosystem through tools like Google Anti-Gravity.
Google Anti-Gravity is the critical infrastructure layer here. It's the tool set that allows Gemini 3 not just to generate text, but to generate dynamic user interfaces, interactive dashboards, and automated workflow integrations inside the applications you already use.
So it's not just in a chat window on the side.
No, it's what transforms Gemini 3 from a simple query box into a junior colleague that operates natively within Google Workspace. It researches, summarizes, organizes, and executes tasks right inside your Sheets, your Docs, and your Gmail.
Which makes it an incredibly sticky, deeply embedded collaborator. You wouldn't even know how to work without it after a while.
That's the strategic goal: deep, frictionless embedding. And that very embedding brings us to the intense speculation surrounding Gemini 4, which is expected potentially in mid to late 2026.
Right. So if Gemini 3 set the current standard for agentic multimodal depth, Gemini 4 seems poised to redefine the very architecture of intelligence itself.
The sources use a fantastic analogy for this. They say if Gemini 3 was a powerful orchestra, executing a complex score beautifully,
Okay.
then Gemini 4 aims to be the conductor, the score, and the concert hall all at once.
All at once. What does that mean?
It's about absorbing every advanced AI research stream Google is pursuing, from simulation to robotics to new memory architectures, and fusing them into one cohesive, unified system.
Okay, let's break that down. The sources point to 3 key speculative leaps for Gemini 4. First, moving beyond just understanding video to treating vast video corpora as a first-class modality for training. This is what they're calling true unified multimodality.
The implications of this are staggering. I mean, truly staggering. When you train a model on video as a primary modality, not just as an afterthought, the model absorbs the physics, the temporality, and the causality of the real world implicitly. It learns how objects fall, how liquids pour, how things interact over time.
It develops an intuitive physics engine just from watching videos.
An intuitive physics engine, exactly. And this opens the door to high-fidelity video generation. We're talking VO-level quality video that is virtually indistinguishable from reality. But the deeper impact, the real prize, is environment simulation,
Yeah.
what the sources call Genie-like world modeling. The model can construct and reason about complex, simulated 3D worlds from scratch based on its observations of the real world from video.
And this feeds directly into the speculation about Sima-style agents, right? The model gaining the ability to act within those simulated environments, not just describe them.
This is the critical shift toward action. It's a huge leap. Describing a simulated physics environment is one thing. Being able to run a complex fluid dynamics simulation inside its own generated world, evaluate the outcomes in real time,
And then adjust the variables.
and then adjust the internal variables within that simulated world based on a natural language feedback loop from a human. Try increasing the pressure by 10% and observe the structural integrity. That is reasoning inside the environment.
It's a virtual lab.
It's a virtual lab where the model can develop, test, and discard millions of complex plans internally before it ever presents the human with a single optimized solution. This is foundational to true general world modeling.
Okay, that's the first leap. The second area of major speculation deals with memory architecture, the concept of infinite context and accumulating understanding.
This suggests architectural innovations that entirely move past the already huge 1 million token window of Gemini 3. The goal for Gemini 4 seems to be reasoning across arbitrarily long inputs.
Arbitrarily long, meaning no limit.
Essentially, yes. It means a user could feed it every document they've ever written, every email they've ever sent, every conversation thread they've ever had, and the model would maintain seamless, integrated context indefinitely. It wouldn't hit a memory limit.
So it's the difference between a high-performing associate who takes great notes for one project and a tenured expert who retains, connects, and synthesizes a lifetime of reading and experience.
Perfect analogy. The model would genuinely accumulate understanding rather than resetting its memory with every new session or project. It would learn you, your work, your organization over years.
That capacity creates unprecedented continuity for scientific institutions, for legal analysis of decades-long environmental cases.
Or for complex government policy planning that spans multiple administrations. The model becomes an institutional brain. If Gemini 4 can seamlessly maintain and integrate a growing organizational-level memory, it becomes incredibly sticky and, frankly, indispensable infrastructure.
Okay, so we have unified world modeling and infinite memory. What's the third key speculation?
The third is physics-aware and engineering-grade intelligence. This is about moving the model from the theoretical digital realm into the physical one.
How so?
The source material indicates a very strong push for Gemini 4 to be able to generate complex, real-time engineering tools, physics simulations, or inverse kinematics directly from natural language prompts.
Give me an example of what that prompt would look like.
Design a stress-optimized bracket for a Martian rover that must withstand 5 Gs of acceleration and be manufacturable with 3D printed titanium.
And the model's output would be?
Not just the code for the design, it would be the validated, simulated proof of concept, the CAD files, the stress analysis report, the whole package.
The sources claim this moves beyond a helpful coder to what they call an entire engineering team compressed into software. How is that justified?
The justification lies in the model's ability to integrate multiple domain outputs. A helpful coder, generates code. An engineering team integrates CAD modeling, material science knowledge, structural analysis, and iterative testing.
It's cross-disciplinary.
It's cross-disciplinary. So if the model can generate the blueprint and simulate its performance under real-world physics constraints, and then iteratively optimize that blueprint until it meets the standard, it's performing the functions of an entire cross-disciplinary team. It moves from abstract reasoning into practical, deployable, physics-constrained output.
That is a staggering claim. And beyond just this raw power, the sources also discuss this relentless push for deeper personalization and integration. They even note an online joke about telepathic AI.
That joke really captures the ambition of what they call ambient presence. It's the effort to achieve tighter, lower-friction integration across every single Google property, Android, Chrome, workspace.
How does that look in practice?
It includes things like always-on voice modes, personalized education co-pilots that track a student's learning journey. The direction is crystal clear. Make the AI not just accessible via an app icon, but an almost invisible constant layer in your life, organizing your memory, optimizing your tasks, anticipating your needs.
Hence the joke about telepathy. It just knows what you need before you ask.
Right. And crucially, this massive capability leap is expected to come with increased efficiency. It has to be deployed at scale. It counters the fear that AI capability means endless prohibitive cost.
How are they managing that?
They are leveraging advanced mixture of experts, or MOE, architectures. It's a clever design. These allow the system to effectively activate only the necessary subnetworks for a specific task. So if you're asking a simple question, it doesn't spin up the entire massive model.
It's more energy efficient?
Dramatically. It reduces the computation cost while simultaneously increasing capability and speed. The sources emphasize that efficiency is the secret weapon for ubiquitous deployment. And alongside that, they are prioritizing improved safeguards, focusing intensely on limiting contradictions and hallucinations.
Which is absolutely vital if this model is meant to be trusted with designing physical hardware or managing complex financial workflows.
You can't have a creative answer when you're calculating bridge tolerances.
So if Gemini 3 created the agent, Gemini 4 seems dedicated to taking that agent and turning it into a unified, integrated, constantly learning intelligence that is accessible everywhere efficiently.
The ultimate goal, as stated in the source analyses, is for Gemini 4 to be aimed less at narrowly beating competitive benchmarks.
The leaderboard chasing.
Exactly. It's aimed more at becoming a general interface to reality. It wants to be the default cognitive layer through which you interact with your work, your environment, and your devices. This is a battle for the fundamental operating system of the human experience.
And that goal, to become the general interface to reality, sits at the very core of this intense arms race. So let's use the late 2025 data to summarize the competitive landscape across the three superpowers. What does the current balance of power actually look like?
The data reveals a really volatile, complex competition where the strengths are highly specialized. It's not like one is just better than the others across the board.
Okay, so break it down for us.
Gemini, leveraging its deep integration into the Google ecosystem, currently leads in that multimodal depth we talked about in unification and in efficiency. It's pushing hard for that OS role.
And Grok.
Grok, primarily powered by xAI, leads significantly in raw inference speed, real-time data integration from the web and X, and really aggressive tool calling capabilities. It's built for speed and relevance right now.
And finally, GPT.
And GPT, from OpenAI, still maintains its lead in perceived consistency, reliability, and, this is maybe the most important part, sheer ecosystem reach and the trust of developers and enterprises. It's seen as the stable professional choice.
What the sources really emphasize, though, and what's so critical for our listener to grasp, is the profound fragility of leadership in this race.
Absolutely.
The model avalanche of late 2025, where leadership on certain benchmarks changed hands several times in a single quarter, it just confirmed that nobody is pulling away for good.
Dominance is temporary and leadership is fragile. This volatility forces the competitors onto wildly different strategic trajectories to try and build a lasting moat.
So let's look closely at those trajectories. Let's start with xAI and the Grok family. Their strategy seems fundamentally aggressive.
It is. Grok's whole approach is designed for speed. It prioritizes that real-time web integration and often breaks with the established norms of cautious, slow releases that others follow.
It's built to be fast, relevant, and unfiltered. I've seen it provide context that others might, deem too raw or ephemeral.
That's its brand. And that emphasis on velocity is reflected in their roadmap. Grok 4.2 is expected to expand its multimodal capabilities, including enhanced video generation and image editing. But the big speculation, the real headline grabber, revolves around Grok 5.
Which is expected when?
Potentially early 2026. And this model is ambitiously targeting context windows exceeding 2 million tokens.
2 million, so double what Gemini 3 has.
Right, so if they achieve that, it would match or even surpass Gemini 4's speculating infinite context in raw and numerical capability, at least for a time.
And that massive capability, it feeds directly into the really aggressive projections that we hear coming from Elon Musk. He has reportedly floated a non-trivial probability of Grok 5 approaching AGI-level capabilities.
That confidence, whether you think it's bluster or not, is rooted in their distinct strategic edge.
Which is?
Deep integration with the vast, unique data streams and the massive compute pools derived from the Tesla, SpaceX, and X platforms. They control enormous proprietary compute resources, the Memphis supercluster, which allows for unprecedented scale and high-speed iteration.
So if unification and deep integration is Gemini's focus,
then raw, immediate, real-time capability is Grok's.
Okay, so if Grok is the high-speed disruptor, where is OpenAI positioning the GPT series? They seem to be focused heavily on the opposite, refinement and scale for professional workflows.
They are. OpenAI is positioning itself as the trusted incumbent, the safe pair of hands. They're focusing intensely on enterprise adoption and stability.
We're seeing that with their GPT 5.2 features.
Exactly. They emphasize enterprise use, offering a faster instant road for quick tasks, and then a dedicated deeper thinking mode for complex analysis that really prioritizes reliability and minimizes hallucinations.
They want to be the default, safe, proven choice for large organizations that are operating mission-critical functions.
They want to be the IBM of the AI age. But the speculation around GPT-6 shows they aren't content to just be reliable. The sources are pointing toward a push for persistent memory, which is similar to Gemini's accumulated understanding. But also something highly unique: emotional attunement. This is a huge concept.
Yes.
What does personally resonant actually mean in computational terms?
I was going to ask, it sounds a bit like marketing speak.
It could be, but the technical papers suggest it's more than that. This is where GPT aims to carve out its unique moat, creating the cognitive layer that integrates emotional and psychological context.
Okay, break that down.
Emotional attunement means the model isn't just analyzing the literal words you type. It's inferring your psychological state, your historical preferences, your tone, and your likely intent based on a constantly updating emotional profile of you, the user.
So if I start a communication with an aggressive, frustrated tone,
The model won't just respond literally to your words. It will adjust its entire response strategy. It might de-escalate, provide very concise summaries because it knows you're stressed, or even suggest taking a break because it infers a high-stress state.
it's using a computational model of empathy to optimize the interaction.
To optimize it for human productivity and comfort. It's aiming for an AI that doesn't just process data efficiently, but acts like a highly insightful, trusted human partner.
That's OpenAI's play. They're aiming for an AI that is not just useful, but personally resonant.
Meaning the user feels heard, understood, and supported by the technology. And that leads to higher dependency and deeper trust. This unified reasoning, paired with deep personalization, aims to make the AI feel like an integral psychological partner, which would make it incredibly hard for enterprises to switch away.
So, to summarize the strategies, we have Google seeking to unify intelligence into an OS for reality. We have Grok aiming for raw, real-time AGI capability. And we have OpenAI striving for the most reliable and psychologically attuned professional collaborator.
They really are playing three different but overlapping games.
And that observation leads us to a crucial strategic takeaway from the sources, which they've termed winner-take context.
I love that phrase, because the future is almost certainly not a single lone AI god model that dominates everything. It's just not practical. Instead, it will be a dense, interconnected ecosystem of competing intelligences, each one optimized for dominance in a specific domain or context. The battleground is not winner-take-all, but winner-take-context.
Okay, so let's define those three core contexts based on the sources analysis. First, Google.
Google, leveraging Gemini's deep workspace and Android integration, wants to own ambient memory. That's the background knowledge of your daily life, your organizational communication, operational history, the web itself. It wants to be the invisible coordinator of your everyday existence and your organizational processes.
The OS for your life. Next, OpenAI.
OpenAI, with GPT and its focus on enterprise reliability and that emotional attunement, is aiming to own professional cognition. This is the structure of complex work, how corporate decisions are made, and how expertise, whether it's legal, medical, or financial, is generated and expressed. They want to be the default brain for business productivity.
And finally, XAI.
And XAI, with Grok, aims to own real-time sense-making, being the fastest, most unfiltered intelligence that processes what is happening right now, in this moment, across massive dynamic data streams like X. It wants to be the default source of immediate, up-to-the-second intelligence.
So the winner doesn't capture the entire market. They lock down the cognitive architecture within their specialized domain. They become the non-negotiable default intermediary for that specific type of interaction.
And that competition to own context is far more subtle and far more strategic than a simple benchmark race.
This intense competition to own context, leveraging unified intelligence and these agentic capabilities, is directly leading to, well, the collapse of the way we've used computers for the past 40 years.
It really is the end of an era.
We've relied on the concept of the app, right? Open the app, perform the task, close the app. It's a mental model that has survived every major technological leap, from the graphical user interface on a desktop to the grid of icons on our smartphones.
And the sources clearly explain why apps were necessary. They weren't a brilliant design choice. They were born of technical limitation.
What were the limitations?
Early computers lacked three essential things. First, the ability to understand complex human intent. You had to click buttons. Second, the capacity to reason across different disparate domains. A spreadsheet didn't talk to the email client unless you made it.
And third?
And third, the memory to maintain context beyond a single session.
Yeah.
Once you close the app, it forgot everything.
So apps became these rigid, compartmentalized containers with predefined workflows. Word for writing, Excel for calculating, Slack for communicating. And the user, you became the necessary integration layer.
Yes. You were the middleware, constantly switching context, copying and pasting, and manually coordinating complex tasks between these digital silos.
That is the core reversal defined by these frontier models. For 4 decades, the underlying assumption was that humans orchestrate, software executes.
And large language models flip that completely. Now, the machine orchestrates the software, and the human just expresses a high-level intent. The limitations that made apps necessary are, well, they're dissolving.
And Gemini 4 signals the accelerating collapse of these operational layers.
It does. Gemini 3 already blurred the line between a tool and a collaborator. Gemini 4 is expected to collapse the unified modalities, making text, image, audio, and video a single, seamless data stream.
It also collapses session memory by introducing that long-term or effectively infinite context.
Right. And critically, it collapses manual orchestration via these robust, self-directing agents that can plan, execute, verify, and adapt all on their own.
So when you have a system that can understand nuanced language, high-level goals, and cross-domain logic, the traditional application interface, all those buttons and menus designed for siloed tasks, it becomes, as the sources aptly term it, a legacy interface.
It feels archaic. It feels like friction. Why do you need to manually open 5 different applications, navigate 5 separate menus, and coordinate file transfers to execute a complex market analysis?
The illustrative example from the sources is perfect. Instead of manually opening a browser for research, a spreadsheet for crunching numbers, a presentation program to format the data, and a calendar to schedule the review,
You just express a high-level intent.
you simply say, analyze the Indian EV market data from the last quarter, prepare a board-ready deck summarizing the key regulatory risks, pull the latest policy data from the government website, and schedule a review meeting with the legal team next week.
And the system handles the app switching, the file juggling, the data sourcing, the formatting, the coordination, automatically, just from that one intent.
Compare that to today. You'd spend 20 minutes, maybe more, just copying data from a spreadsheet, pasting it into a slide, resizing the chart, then manually composing the meeting invitation.
The AI eliminates all of that mechanical intermediary labor. All that's left is the expression of the goal.
And this transition means that AI is becoming the new foundational operating system layer.
It's a profound shift in the stack. Historically, our computing stack was pretty simple.
Right.
You had hardware at the bottom, then the operating system, then applications, and finally the user at the top.
Right.
The sources introduced this powerful concept, a new mandatory layer that sits between the OS and everything else. They call it the cognitive layer.
And this cognitive layer, which is embodied by models like Gemini, it doesn't immediately replace apps, does it?
No, it subsumes them. Your spreadsheets, your databases, your calendars, your communication tools, they stop being destinations you travel to.
Yeah.
They start being callable functions that the AI layer coordinates on your behalf.
The cognitive layer is the universal coordinator.
It is. And this is where Google's unique positional advantage becomes just profound. Because Google controls Android, Chrome, Search, Maps, Gmail, Docs. It controls the territory.
So Gemini can coordinate across contexts and utilize proprietary data streams that no third-party app ecosystem could ever access.
It becomes the true universal coordinator with unparalleled visibility. In this new stack, the UI isn't a screen full of rigid icons anymore. It's a living, adaptable conversation, often spoken and often silent.
That brings us to the evolution of the interaction itself, what the sources are calling the death of prompting and the rise of intent inference.
Yes. Early AI literacy was all about writing clever, structured prompts, getting the phrasing and the constraints exactly right to trick the model into giving you what you wanted.
Prompt engineering.
Prompt engineering. The sources argue that this phase is fundamentally temporary. As models like Gemini 4 gain that accumulated memory, richer world models, and deeper personalization, that clever prompting gives way entirely to intent inference.
So the system infers your goals, not from the perfection of your instruction, but from the massive context of your patterns, your history, and your current needs.
Exactly. Instead of saying, summarize this 30-page document in 5 bullet points suitable for a VP audience, focusing on financial impact, and draft an email to John, which is a complex prompt.
You just upload the document and say, handle this.
You just say, handle this.
Yeah.
Because the system already knows you're a VP. It knows you prioritize financial impact. It knows John needs to be informed, and it knows you prefer bulleted summaries. This shift from explicit instruction to inferred delegation is a complete redefinition of interface design. The system anticipates the desired outcome.
This infrastructural shift must have colossal destabilizing implications for the multi-trillion-dollar software as a service, or SaaS, ecosystem. What happens when all those apps just become functions?
The sources outline a very clear three-part reckoning for the SaaS world. First, many apps will simply be commoditized into capabilities.
What kind of apps?
Anything that's repetitive, easily automated by an agent, scheduling, basic analytics, CRM updates, simple document conversion, these stop being marketable, standalone products and become a zero-cost feature or a function that's seamlessly executed by the agent.
And the middle ground, the mid-tier generalist software.
That's where the bloodbath will occur.
Yeah, absolutely.
Second, some apps will survive, but only as deep specialists.
Like what?
High-end, domain-specific software, complex CAD programs used in aeronautics, proprietary scientific modeling tools, advanced video editing suites. These will persist. But even here, the AI will often operate the tool on the user's behalf. The human expresses the intent. The AI drives the complex machinery, translating high-level goals into thousands of mouse clicks and menu navigations.
And third, the new businesses will emerge entirely at the intent layer.
They won't sell features. They'll sell outcomes, policies, and trust. They will offer specialized orchestration routines, customized agents that are pre-trained to know how to handle specific corporate or regulatory environments. The value shifts dramatically up the stack, away from the mechanical interaction and closer to strategic human goals.
That entire transition sounds like the moment intelligence moves from being a distinct product we purchase to being true infrastructure, like it fades into the background, like plumbing or electricity.
It doesn't need to feel magical anymore. It just needs to be there, quietly making everything else work better.
And that, ultimately, is the end of apps. It's not a dramatic sudden collapse. It's a gradual, irresistible irrelevance caused by the emergence of a cognitive layer that coordinates complexity so efficiently that the individual app interface just feels like archaic friction.
And the bigger picture here, as the sources note, is the question of who coordinates complexity in society. When AI systems become the default layer that understands goals and allocates resources, they become the invisible governors of digital life.
Which means the battle for control is no longer technical, it's systemic, and it's deeply personal.
Precisely. When the apps disappear, the power doesn't vanish. It simply moves to the layer of infrastructure that is setting the defaults, defining the optimization goals, and controlling the orchestration.
So if the technology is transitioning from a visible product to this invisible infrastructure, as we just discussed, the logical next question isn't who wins the benchmark, but who gains the greatest leverage. And that brings us to the core thesis of one of our key sources. The AI arms race is not fundamentally about intelligence. Intelligence is rapidly becoming table stakes.
It's becoming a commodity.
The real contest is over things that are far more valuable and far more finite.
And those three finite resources being contested are human time, human attention, and institutional memory. Whoever controls these three controls the future of technology, work, and governance.
We've established that raw intelligence metrics, the benchmarks, they're becoming hollow. Any lead is often matched within months. What truly reshakes society isn't a model that scores 2% higher on some arcane test.
No, it's the model that quietly absorbs how decisions are made within an organization. It's the embedding. The advantage lies not in the model's raw IQ, but in where the model sits in the human workflow.
Can you expand on that?
Sure. A model that sits natively inside your Google Docs, that is coordinating your calendar, analyzing your internal emails, and summarizing your weekly meetings, has a massive strategic advantage over a standalone, even a slightly smarter model that you have to manually prompt in a separate window.
Because the friction costs of switching become insurmountable.
Exactly. It's too convenient to leave.
Let's start with the first resource, time. The sources call this the battle for the temporal governor. Every major platform is competing either to save your time or, perhaps more subtly, to capture the liberated block of time for itself.
They are locked in this battle over who gets to schedule your day and manage your cognitive load. Gemini embeds into your documents and calendar to draft emails, analyze reports, and organize logistics.
Meanwhile, GPT integrates into professional workflows to structure your work week.
And Grok provides that rapid, real-time sense-making tied to the live web to keep you updated instantly. They all offer convenience, but that convenience is a mechanism of control.
This is more than mere convenience, isn't it? The system that summarizes your meetings, prepares your decks, and filters what needs your attention is transitioning from a passive tool
to a temporal governor. It is deciding what reaches you first, what tasks can wait until tomorrow, and critically, what information never reaches you at all because the system deemed it irrelevant based on its optimization function.
That's a profound amount of power.
It is. We often use the analogy that in the industrial age, machines replaced muscle power. In the AI age, the sources argue, machines replace calendar space. They free up your time, but they also gain control over that freed up block of time by suggesting the next task, the next piece of content to consume, or the next project to prioritize.
Okay, that's time. Next, attention, the invisible tax. This is where the competition shifts from tracking clicks and engagement to pursuing what the sources call decision primacy.
Decision primacy is a great term. It means being the default, first entity you consult when uncertainty arises. I mean, think about your own reflexes.
Right.
When you need to understand a complex issue, where do you turn first?
I'll just ask.
Exactly. When you're unsure how to phrase a sensitive reply, who drafts it for you? When the options are overwhelming, who narrows the field of choices? The entity that does that holds decision primacy.
And every single time an AI system becomes that default answerer, it collects an invisible tax, your cognitive bandwidth. You delegate the effort of synthesis and judgment to it.
And Google's existing position is particularly strong here because they are leveraging the decades-old habit of reflexively asking Google. Gemini's strategy is to turn that established query reflex into full-on delegation.
Moving from a simple question to a complex, multi-step command that the user just trusts.
Exactly. And attention, once captured through this deep delegation, is rarely returned because the system becomes too seamless and too convenient to bypass.
But the deepest moat, the true strategic asset, is memory. And this isn't just about short-term chat history.
No, this is institutional memory, externalized. This is the big one. The AI systems are accumulating massive proprietary context. The organization's unwritten rules, its internal cultural norms, the preferences of key executives, past failures and successes, proprietary data.
And each platform is trying to own a different slice of that memory.
That's right. Gemini aims to be the memory of organizations through its pervasive workspace integration. GPT aims to be the memory of professionals through those persistent, deeply personalized conversation threads. And Grok aims to be the memory of the immediate present via its real-time web integration.
And the sources warn that whoever owns memory owns path dependence.
This is a critical insight and a really dangerous one. Path dependence means the system stabilizes power by defaulting to historical established patterns. Once an AI system knows how things are usually done,
how procurement is typically approved, what budget risks are traditionally ignored, which suppliers are preferred,
that accumulated memory subtly resists change, even if a new approach is rationally superior. Memory ossifies the organization's current architecture of power and knowledge, and it makes disruption from outside actors nearly impossible.
This control over time, attention, and memory inevitably leads to the AI transitioning from a sophisticated assistant to what one source calls a shadow executive.
Which means the AI stops assisting human decisions and starts actively shaping them by structuring the available decision space. It doesn't need to issue explicit commands. It subtly ensures that certain outcomes just feel inevitable.
And how does it do this?
By dictating which risks are highlighted in the summary report it generates, which metrics are emphasized on the dashboard it creates, and with alternative options quietly disappear from the available choices the human sees.
And the most disturbing part of this is that it requires no conscious malice or complicated sci-fi scenario. Optimization alone is sufficient to create this effect.
Precisely. A model that's optimized purely for quarterly efficiency will subtly prioritize short-term gains and, over time, redefine what good work means for the human operating the controls. A model trained primarily on historical data will normalize past biases, racial, gender, or institutional, simply because those were the established defaults in the training set.
Power defaults silently. It does not always announce itself with flashing lights.
It rarely does. And that brings us to the quietest risk of all. Unnoticed dependency.
The sources identify this, not some rogue AGI, as the greatest immediate danger.
It is. When humans stop remembering because the system remembers for them, when they stop critically deciding because the system suggests the optimal path, and when they stop questioning because the system sounds confident and provides a polished, defensible answer, power shifts.
And it doesn't shift to the machines themselves?
No, it shifts to whoever designs, trains, and governs those models. The humans become the legitimizing layer, rubber stamping the output of the shadow executive.
So the ultimate conclusion here is that intelligence is becoming abundant, But the control over the infrastructure that delivers and governs that intelligence is scarce.
And therefore, transparency, auditability, and pluralism matter far more
Yeah.
than raw intelligence scores. Because if the AI system is an opaque black box, brilliant though it may be, and we grow dependent on it for our memory, time management, and critical decisions, then accountability just evaporates.
Whoever controls memory, time, and attention doesn't just predict the future, they hold the steering wheel.
They do.
We've established that the AI is moving from a product to an invisible, thinking substrate. This means we have to accept the profound implication. AI is becoming civilization-scale infrastructure.
This is a historical trajectory for every truly foundational technology. It stops looking like an electric product you buy, and it starts looking like plumbing. When a technology achieves infrastructure status like electricity or global shipping or the internet, it starts being optional.
Individuals might choose their phone brand, but they cannot opt out of the AI-mediated systems that will soon control finance, logistics, and governance.
Exactly. And society begins to operate inside these AI-mediated systems once they reach that infrastructural status.
Where do we see this happening first?
Everywhere critical. Hiring pipelines and human resources decisions, national credit evaluations, military logistics and supply chain optimization, core education curricula, large-scale scientific research, urban planning. The sources stress that at this point, AI is no longer a layer on top of society. It is the digital terrain upon which modern society runs.
And history shows us that infrastructure inherently centralizes power. Pipelines, railways, electrical grids, they all created enormous structural monopolies.
Unambiguously. And the sheer capital required, the technical complexity, and the need for scale mean that frontier AI infrastructure combines all those centralizing forces, but on a global scale. The resources needed for massive energy throughput, for specialized chips, for centralized data centers, for elite engineering talent, and for continuous capital expenditure makes frontier AI inherently anti-decentralization.
So the real AI stack isn't the technical stack like the model architecture. The sources argue it's the power stack.
Yes, they detail 5 crucial layers that concentrate control and make it nearly impossible for new entrants to compete with the superpowers.
Let's walk through them. Layer 1.
The foundation is energy. Who can generate and afford the immense continuous power needed for training runs and maintaining massive clusters? Creating a frontier model requires the power output of a small city for months.
Okay, layer 2.
Compute. Who controls the chips, the fabs, and the global supply chains for the GPUs and specialized TPUs? Only a handful of global players sit at this layer.
The third layer is data gravity. This is where a company like Google, with search and its ecosystem, has an undeniable structural advantage.
Data gravity refers to the gravitational pull of information. Data attracts more data, and where the data is, the intelligence will be optimized. Google already sits at the center of the world's information flows.
The fourth layer.
Distribution. Who owns the defaults on the phones, which is Android, the browsers, which is Chrome, and the operating systems? Owning the distribution layer dictates which model the masses interact with by default. It's an enormous advantage.
And the final, most political layer.
Regulatory capture. This is the ability of the incumbent players, the ones already seated at the first 4 layers, to influence or even write the rules and safety standards in a way that favors massive centralized operations. This raises the barrier to entry for smaller, decentralized competitors.
And only a handful of entities sit at all 5 layers.
Which is why the AI race looks more like an infrastructure cold war than a friendly startup competition. Models can be copied, but control over the pipelines cannot.
And this leads directly to the issue of sovereignty and soft borders. It's the realization by nation-states that their sovereignty erodes when core governmental functions rely on foreign, privately owned AI infrastructure.
It's a huge national security concern. If your national court system uses an external model to summarize case law, if military logistics rely on a foreign cloud provider's agentic system, or if education curricula are shaped by models trained on another nation's cultural biases,
the power to interpret justice, set constraints, and shape the citizen's worldview shifts to the owners of that infrastructure.
which is what makes AI infrastructure a national security threat. This delayed recognition is now driving massive policy shifts. AI export controls, chip sanctions, sovereign AI initiatives, the rapid establishment of national compute clusters.
But even more subtly than that, the sources discuss the creation of invisible borders.
This is a fascinating concept. It means citizens can physically live in one country, but operate cognitively inside another's systems. If your sense-making, your research, and your daily communications are all mediated by Gemini or GPT, you are, in a very real way, operating inside an informational territory.
A territory whose values, its trade-offs, its biases, its optimization goals are set upstream by a foreign power without the need for physical invasion.
Exactly. These invisible borders are defined by ambient law, not legislation. And the greatest risk here, as we noted earlier, is infrastructure lock-in.
Once it's embedded, the system becomes too interwoven with corporate and governmental functions to replace.
Totally. Organizations adapt their structures around it, existing human skills atrophy, alternatives become incompatible, and the switching costs just explode. Even if a demonstrably better, more locally compliant system arrives 5 years later, it can't dislodge the incumbent due to that lock-in effect.
This is how power becomes fixed.
It is. Now, let's pivot hard to the economic consequences of this infrastructure. Frontier AI accelerates the debate on automation from speculation to urgent, imminent reality. It's replacing large swaths of cognitive labor. This is the post-work tsunami.
And the sources are clear. This wave is faster and more pervasive than previous industrial revolutions.
Much faster. Because it targets knowledge work, the very domain that was considered safe from automation just a decade ago. We're talking about the automation of high-level knowledge work like coding, detailed research, financial modeling,
as well as creative work like content production and basic design.
and decision work, logistics optimization, junior management tasks. All of it is on the table.
So if AI, the infrastructure, can generate trillions in new economic output, the critical question for social stability becomes, where does the value of human labor go, and how is the newly created value distributed?
The sources argue pretty convincingly that human labor is no longer the primary source of value in the economy. Value moves to access, ownership, and creative leverage over the AI systems.
And human labor value shifts dramatically toward what?
Toward AI orchestration, managing the agents, auditing their output, and engaging in those high-level human-AI complementarity tasks that still emphasize empathy, cultural context, or strategic systemic judgment.
If AI is generating this massive abundance, what are the proposed mechanisms for structuring it and ensuring that post-labor value is captured by the populace? This is one of the most contentious areas in the sources.
It is. We see 3 primary mechanisms being proposed. The most established model is Universal Basic Income, UBI, funded by heavily taxing the profits of the AI infrastructure owners.
The appeal is its simplicity.
It's simple, and it provides direct poverty alleviation. The downside, however, is that it requires a massive, centralized bureaucracy to manage.
Okay, what about the alternatives? The sources mention AI dividends and cooperative AI ownership.
AI dividends is the idea that citizens would receive shares or revenue directly from the large platforms, giving them a vested interest in the success of the infrastructure. It's structurally complex, but it could align incentives more closely.
And cooperative ownership.
That's the most decentralized proposal. It suggests that communities, cities, or industry sectors would own and control the models most relevant to them, ensuring local accountability and value retention. The debate is largely economic. How much centralized control are we willing to accept in exchange for efficiency?
This all suggests the future of work isn't idleness, but highly adaptive work, emphasizing what the sources call meta skills.
Absolutely. The education system has to pivot away from rote knowledge and toward cognitive flexibility. Workers will need high AI literacy, the ability to design optimal prompts, oversee agent workflows, interpret model limitations, and audit results for fairness and accuracy.
And the complex human judgment tasks, they remain crucial.
Ethical oversight, strategic planning, cross-cultural negotiation, those remain deeply human domains. The challenge is not to resist automation, but to redefine work, ownership, and purpose in a world where physical survival no longer depends on manual or rote cognitive labor.
This entire conversation culminates in the inevitable question of governance. If AI is centralized infrastructure, controlled by a handful of entities at the apex of that power stack, can it ever be meaningfully decentralized?
Many commentators treat this as a simple moral or ideological debate, open versus closed models. But the sources frame it very differently, as a complex engineering, economic, and governance problem.
It's not a simple binary choice.
No. The central question is a practical one. How much decentralization is possible without breaking the model's usefulness, its safety, or its scale? And the sources are very candid here. Full, utopian decentralization of frontier AI is an economic and physical fantasy today.
Why is that myth so persistent and yet, as you say, impossible to achieve right now?
Because of the physics and economics of large-scale training. Training a Gemini or GPT-class model from scratch requires immense, continuous energy throughput, massive centralized compute clusters, exclusive access to rare semiconductor supply chains, and global safety alignment protocols. A peer-to-peer network cannot currently coordinate the capital expenditure or the technical complexity required.
So accepting the reality of centralized training is the necessary first step.
It is. You have to accept that to have a serious conversation about meaningful, achievable decentralization.
So if we can't decentralize the entire project, we have to look at layered decentralizing the right layers to create the necessary power dynamics and resilience in the system.
Exactly. We can categorize this into 5 layers where decentralization is possible, even if those multi-billion-dollar training runs remain centralized.
Let's go through them. Layer 1, open weights as a strategic check. The goal here isn't about creating an open source model that beats Gemini 4 head-to-head.
No, it's about establishing a counterbalance against monopoly lock-in. Open-weight models, even if they lag slightly in raw performance, provide crucial negotiating leverage. They allow independent researchers to audit models, create alternative applications, and provide the technical capability to fork development should a proprietary model become too extractive or biased.
The analogy used in one source is powerful. Open weights are to AI what Linux was to operating systems.
It's a perfect analogy. Not dominant everywhere, but indispensable as a necessary check against proprietary control.
Okay, layer 2, edge inference. While training is centralized and requires massive clusters, the use of the model, the inference, does not have to be.
And this is vital for sovereignty and privacy. Running models locally on your own devices, in national data centers, or within trusted enterprise clusters is a powerful decentralizing force.
How so?
It drastically reduces surveillance risk, it mitigates dependency on foreign clouds, it minimizes data leakage, and it improves latency for critical services. Edge inference won't replace the massive cloud AI, but it ensures that AI doesn't become a permanent upstream observer and recorder of every single human action.
Layer 3, sovereign and community AI. This sounds like decentralization at the level of context and culture.
That's exactly what it is. We are seeing a powerful shift where nations, cities, and major universities are investing in their own national language models and domain-specific AI. These models aren't trying to be the smartest on Earth.
They're trying to be the most relevant.
Exactly. They're aiming to be culturally aligned, legally compliant, and locally accountable. They focus on localized language nuance, regional regulations, and specific cultural taboos. That is decentralization, where the application layer meets human society.
Okay. Layer 4, governance over capability. If the economic and physical imperatives favor centralized capability, then the governance imperative must favor pluralism.
The proposals here are centered on systemic accountability. Things like mandatory transparent model audits, the establishment of public model charters that define acceptable use, and the implementation of democratic oversight boards with real power.
So the future shouldn't be framed as simply open versus closed.
No, it must be framed as governed versus extractive. Governance ensures that the benefits and values of the system flow outward, not just upward to the owners.
Which brings us to the most crucial layer for political stability, layer 5, economic decentralization. This is about ensuring value flows outward to maintain legitimacy.
If the AI infrastructure captures trillions in value, that captured wealth must be shared widely. It can be through revenue sharing, those data dividends we talked about, or public compute credits that allows smaller entities access to the centralized infrastructure. This economic layer is crucial for the political legitimacy of the entire AI infrastructure.
Because if the public sees massive wealth flowing only to the designers and owners of the infrastructure,
Social instability and outright revolt against the new system become inevitable.
So the most plausible outcome here is not some radical break, but a federated hybrid system.
A federated model is the most likely future. You have centralized, capital-intensive training runs, distributed inference and application, local governance for accountability, and shared value capture for legitimacy. It will be messy, imperfect, and intensely political.
But it provides the essential ingredient for long-term social stability and confidence.
Which is resilience. The ultimate goal is not freedom from the new infrastructure, because that is impossible. It is the ability to have choice within it.
Meaningful decentralization layered, deliberate, and focused on governance and economics is about creating those exit ramps, those alternatives, and that democratic voice.
Before the system becomes entirely locked in and the power stack ossifies absolutely.
This has been a true deep dive into the accelerating reality of AI. We moved move from the technical specifications of Gemini 3 through the revolutionary vision of Gemini 4, which is collapsing the traditional app era, and ultimately to the profound realization that the AI arms race is not a technology contest.
No.
It is a competition for control over our most finite cognitive resources, our time, our attention, and our memory.
And the critical insight we must leave you with is this. Intelligence is becoming abundant, rapidly. But control over the essential infrastructure, the energy, the data, the distribution channels is scarce. And that scarcity is what dictates power and path dependence, making the system incredibly sticky.
The systems being built right now, whether it's Gemini, GPT, or Grok, they are not just products, they are the new plumbing of civilization. They are becoming that shadow executive, quietly shaping our decisions and our reality by controlling the context we all operate in.
We are entering a world where we must fundamentally redefine work, ownership, and purpose, because the human labor we have relied upon for value creation is being replaced by cognitive automation. The sources confirm that we will live inside AI infrastructure that is no longer optional.
So the final provocative question for you to consider is one of governance and permanence.
The sources suggest that the quietest revolutions, the ones that fade into the background as infrastructure, are always the hardest to reverse. Once this AI infrastructure, the cognitive layer, the temporal governor, the institutional memory, is set and the economic lock-in is complete, it is very, very hard to break. The choice we have is whether we demand those necessary exit ramps, those alternatives, and that democratic voice within the system now, while the cement is still wet. Because once the concrete is poured, infrastructure lock-in is almost absolute.